so ignore this part. These are going to be no calculator. These are going to be no calculator things, so don't worry about that. Okay, so here we have a function, and we got 3 parts here. First, find the slope of the secant line between x equals 1 and x equals 5 of this function. Then find the slope of the tangent line at x equals 3, and then related, b and c kind of go together, and then find the equation of the tangent line at x equals 3. Of course, slope of the tangent line is one of the things you need to get the equation of the tangent line. So slope of the secant line between 1 and 5, slope of the tangent line, equation of the tangent line. Okay, go. Yeah, I don't care. Use your notes, talk to a partner, whatever. Talk to a neighbor. What's a secant line? What's a tangent line? Touches the curve at 1 point. What's a secant line? Touches at 2 points. Right? Touches at 1 and at 5.
I was just playing along.
Just teach us class.
Oh.
I knew that.
How do you do this?
I'll take it. So yeah, you just need to find the y.
Okay, so let's plug in on what?
Trey, shut up.
You actually write something down too.
So x at 1.
So the first coordinate is 1.
Negative 1/2.
Negative 1/2. Okay, so the second coordinate is
5 over 1/2. 3 over 6.
So 5 1/2.
And then the slope between those.
So that's y over
Rise on
x.
run.
Y minus y over
and
x
it goes
minus
over
x.
4.
So
It'd be 1/4.
y minus y.
And
So
eight
there's
is
1
1/2.
over 4. Yeah, it'd be 1/4.
1/4. So what's it?
Whoa. Okay. The slope of the
A. That's A. B.
I don't know. I forget. Oh, we have to pick a really small slope. But I don't want to. Yeah, I'm like,
No calculator.
We create our own.
what? You don't have to create your own. Yeah, do that H.
Oh, yeah.
The answer. That one thing with the H in it, you know, where it's all over H. What? Where's your guy at all?
That's for derivatives.
Yeah.
Yeah, you need
that one.
Yeah.
He'll show
Sure.
us. Let's just wait till he puts it.
All right, let's just wait.
Wait, is that right where you do the slope of 3 and the slope of course 3 minus h or whatever? All
3.
I mean,
Let me rephrase what I said about how glad I was that you guys are still in this.
that's like the derivative.
I don't even know.
Yes, you did.
I feel real down. I can fill up a water bottle. I'm very.
It's funny you asked that because I was just earlier preparing my speech for my sophomore Algebra 1B class. One of my rules is, because they're always late from lunch or whatever, wander in the halls. I said, hey, if you're late to class, don't be asking me to go fill a water bottle or go to the restroom. You know, that's one thing I always tell them. It's funny, you just have to late.
I just set my watch 2 minutes early because the bell rings like a minute early. 4.
Yeah, go ahead.
I can't.
Yes. So if you don't know what to do and you've talk to someone else who doesn't know what to do, then I would find somebody else to talk to.
You talk to everyone and nobody knows.
Of it, and then, guys, just do the derivative of it and plug it in. Yeah.
Once you figure that one out.
Yeah.
Did you get a number over, like,
That's right.
yeah. Well, I was saying, did you get, how do you punch it? Did you
Oh,
get
that's
one
funny.
number?
Yeah,
Did you
just
get final? So, what you're saying, the final only over
Times x plus minus x minus 2.
Yeah, slow.
Yeah.
Plus 1.
It's tricky, a little ridiculous.
Okay.
I don't want to be alone. Oh, and then
Plug it in.
Why are you scoring?
I got something to do.
You just do the derivative and plug it in.
What you get for B?
Yeah.
Joe, did you get 3/16?
Yes.
Yes.
Wait, don't start yet. I gotta do that using really close points. Y equals
Yes.
3, 6,
Closest to tangent is what you have to do.
x minus
So there's two.
Wait, so
One
now we
really
have to
dumb
plug
way and the other
3 minus 2 is 1.
That'd be 3/17. 16.
There you go, Robert.
What'd you get for your
Squared
equation?
plus squared.
What? What'd you get for the
Yeah, you can even add like.
Okay, fourth. 1 out of 3 wouldn't be bad. I think I did get 1/4. That would have.
All right.
3 is
So, after some really crazy ideas and
A lot of effort.
interesting
I blame everything on
comments, but, yeah, okay, first day after break, so catch a little bit of slack. But the reason I picked this problem is this is really the fundamental idea, right, of everything we did last term. I mean, starting with the very first day. Now, and another reason I like this problem is I meant for it to start easier, okay? Because so slope of the secant line, so back to that, slope of the secant line, which we had to remember what's a secant line, well, it's a line through 2 points. That's algebra, right? This is 8th grade for you guys, most of you guys, right? Just slope between 2 points. So what'd you do with the 1 and the 5? Plug them in to find the y's and then just do a slope, right? Just do a slope calculation, okay? That's all it is. That's it. And what would have made this more challenging from a vocabulary standpoint, where the way this is usually asked, on like a multiple choice, like in these packages or something, wouldn't have been find the slope of the secant line. It would have been find the average rate of change of this function from x equals 1 to x equals 5. That's the same question. Find the average rate of change. But the problem is, and I've said this many times, so hopefully it's starting to sink in, but the word average, people get thrown off. They think they're supposed to add something up and divide by how many you have or something when they hear the word average, and that's not what we think of. And hopefully you remember me saying this many times. The average rate of change means slope between 2 points. The slope between 2 points is average rate of change. In the very first day, we talked about that door opening. How fast is that door opening, right? Between 1 and 2. That was average rate of change. But then we were interested in calculus, we become interested in what? The instantaneous rate of change. How fast is that door opening at a point? And of course that became That's also the slope of the tangent line, which is the slope at one point. And then that's where you guys were talking about the plus h and the definition of the derivative, which is great if you're thinking of that. But why would you use that here, right? I mean, why put in like I heard somebody said 3 and 3.001. That's great. At one time, that was the only option we had. But now what can we do? Do the derivative. I mean, that's why we did the gateway test, right? That's why we did all those derivative rules, is because that gives us the instantaneous rate change. Now, there are going to be problems where, because of the way they ask it, you have to use a 3 and a 3.01 maybe, or something like that, or do a 3 plus h. Maybe it's a limit problem that looks like the definition of the derivative or something. So yeah, we need to know that. And it's good to know where that came from, that those derivative rules come from slope of two really close points. That's all really good stuff to know. But to just do the slope of the tangent line problem with this, you just do the derivative, which is a quotient, right? I heard somebody talking about that too, the quotient. Okay, so that's, but again, these are just very fundamental concepts from last term, and that's what I want to start with. Okay, so I would like to see you get in the habit of using this, though, this notation, showing your work. We talked about showing your work. So like if this was these packets, now when we take the actual midterm test, I'm not going to grade your work on the multiple choice section. Scan sheets, I'm going to scan them, you know, and you get graded on right or wrong. So there's no penalty for guessing. At one point there used to be a penalty for guessing on the multiple choice, kind of like, is it the SATs? The SATs,
not anymore.
did they take that away from those two? I know in the ACT for sure you could guess. The SAT, there used to be a penalty for guessing. There isn't anymore. Do you know how that works?
You get a fourth of a point taken off.
Well, it depends. It depends, not now, but do you know how that works, that penalty for guessing? You lose points based on how many choices there are. So if there are 5 choices, A, B, C, D, and E, then you would take a fourth off. And here's why. So if say your second grade brother took the AP Calc test, the multiple choice section, just filled in the bubbles, right? Well, if there were 5 choices, how many would they get right? Theoretically.
How many questions do we have?
Well, it doesn't matter. Well, it's okay. I meant percentage-wise it wouldn't matter, but let's say there was 100 questions, and there was 5 choices, and they were just filling in bubbles. How many would you get right? 20. 1 out of every 5, right? You have a 1 out of 5 chance. So theoretically, might get more, might get less, but theoretically you get 20 right out of 100. So your second grade brother would get a 20%. Well, your second grade brother, maybe he's a genius, but probably doesn't know any calculus. So they don't deserve a 20%. They deserve a 0, right? Based on how much they know. So if you think about it, they would get 20 right and they'd get 80 wrong. So what you do in a penalty for guessing, you get 1 point for every right answer, and then you would lose a fourth of a point for every wrong answer. So if you take this times, just divide by 4, you get 20, and then you subtract that, and then they get the grade that they deserve. So that's why it's a 4. So if you had 4 choices, A, B, C, D, then you would take a third of a point off for each one. Okay, that's how that works. Okay. So anyway, just a little math. So I thought I'd throw it in, but they don't do it anymore. So you have to worry about it. And I think the reason they did away with it is they looked and they adjusted the scale, because now the scores are a little higher than they used to be because there's no penalty. So now you can, like I said, somebody who deserves a 0 is now getting a 20. So it raises the scores, but they just adjusted the scale accordingly. And it kind of takes care of itself. And I think what they found was people spent too much time worrying about the penalty and should I just leave a blank or should I guess? What should I do? And then you end up just spending too much time worrying about that and not just focusing on what you know. So anyway, so you just guess if you have to. The reason I brought that up is, so on the actual midterm exam, I'm not going to grade your work, but when we're reviewing and doing these packets, I want you to be showing your work, because that's when I pick them up and give you points, it's a lot for effort. So I want to see the work that you've done. Okay? So you look up in the answer book and the choice is A, and you just put an A in there and don't do any work. Now, I do realize that there are some problems you really don't need any work. There's very little you need to do. Okay? But I think you want to treat these like they were free response questions. And so if you're doing the slope between 2 points, I think you ought to write down that you're doing that slope. I think you ought to do this. here. Okay, even if these are no calculator, even if you're doing some of that in your head, like you ought to write down at least one of those two lines there and get in the habit of doing that. If they're free response, you would probably be getting points for that. If it's missing, you would lose points. So get in the habit of doing that even on the multiple choice. But I do recognize there are some problems you probably don't have to do very much. So when I grade them, you know, I won't count off for that. But there are problems where I know there needs to be some work. I'll probably pick out several of them, and I will pay particular attention to those when I go through your packet. And if you don't have any work on those, you know, then that'll probably cost you a little bit. Okay? Anyway, we'll talk more about that as we go on. 1/4 is the answer I got. So you talked about the derivative here. Now, since we're going to plug in a 3 anyway, you don't have to simplify. Because the danger is you'll forget to distribute this negative. You know, if you're going to plug in a 3, you might as well just plug it in up here. Right? Because if you screw this up on your simplifying, then you're going to get a wrong answer down here. Okay, which might get you in trouble. So be careful with that. Because you're just trying to get the 3/16 part. But here's how the derivative would simplify. And then, of course, now all that's left is to just do the tangent line. So you got to plug a 3 back into the original. It's not this 1/4. That's not the same thing. We plugged this 3 in here and got 1/4. So you put in your point, and of course your slope, and there's your tangent line. So again, a pretty fundamental idea from earlier this year. Okay, let's continue that thought process and try this one. This should go quicker here. Okay, so do that one. Now there is one. This is feet. The units on this S function is a position function. So what they meant is a measure of feet traveled at a certain number of seconds, but not per second. So I'll just avoid confusion. So the S function's in feet. All right, here you go. And yes, this is no calculator, so do a little bit of work. All right, so average velocity means what? Slope between 2 points, right? Average rate of change. If it's position, this is a position function, feet, the average rate of change would be the change in feet. That'd be feet per second. How many feet did it travel in how many seconds? Well, how many feet it traveled would be the plug in a 7, plug in a 1, see where it was, subtract those. Let me hang on here a second. Alright, so it's basically the same problem. Just has some units on it and it's a little different lingo, but we talked about average rate change. So I just plug those in, I got -2/9. Okay, feet per second, probably would want to have the units. Again, on the AP test, they're pretty picky. I mean, they're pretty specific. They'll say, be sure to include units. When they say that, pretty good bet there's going to be points for the units. If they don't say it, usually means there's not going to be points, but I would just get in a habit. If it probably got units, you ought to put units on the answer. Okay, typically what they do is in the question, they'll put the units. So they'll say something like, give the average velocity in feet per second between t=1 and t=7. So when you write -2/9, automatically you've answered it in the right units because it said in the question in feet per second. So they'll put that in there. And other times they'll say something like this: average velocity between t=1 and t=7. Be sure to include units. You know, and then it's like, okay, I better do it. But just get in the habit of always doing it. All right. So then the instantaneous, we do the derivative, right? Now, how many people did the quotient rule on that one? Okay, now, what I had typically said, if I have a constant in the top, or a constant only in the top, or a constant only in the bottom, I would use quotient. Doesn't mean you don't have to, it'll work. The problem is a lot of people mess up when they have a constant. Now, for sure, I would not when I have this. If I have a 6 down there, I'm going to write that as 1/6 t plus 2, and then I'm going to do the derivative, which would just be 1/6, and it'd be way easier just to do that than trying to do a quotient rule. If I have a constant only in the top or a constant only in the bottom, I'm typically not doing quotient rule. But here, go ahead if you do. The derivative of 6 is 0, which is going to wipe all that out, minus the 6 left alone, derivative of the bottom is 1, so we end up with this. Usually what I do instead, though, is I would write, if I have a constant only here, I would bring that up like this, do the chain. But it doesn't matter. As long as you do it right. I've seen people screw this up so many times, I tend to advise people not to do it, but it's up to you. So you bring the -1 down, drop that to -2, derivative inside is 1, and since we're going to plug in a 4, we probably don't want a negative power, so I'm going to drop that down to the bottom. Either way, you get the same derivative.
How many points would be for not having label over there?
Well, it depends. If the problem said units, that's probably 1 point. I mean, and maybe this problem altogether is worth 5, and the units might be 1. Okay. Anyway, plug in your 4, and you get that right there. Okay. Now let's do a little bit of limit work here. Oops. Let's try. Here we go. Okay, let's do number 2. You got 6 little quick questions here. Number 2. Now let's assume, we'll go ahead and assume here that this levels off right here at this. Doesn't quite, but we'll assume that levels off here, and of course this levels off here. And let's assume that's an open circle right there because of the vertical line test. We'd have to have that. Okay, and let's answer these 6 limit problems right down here. Okay, answer those real quick. All right, 2 from the left. 3. This car on the left side at 2 is going to meet right up here at 3. 2 from the right, from the positive, is meeting right down there at 0. Even though there's open circle, we don't care. Car is meeting right there. What's the limit as x approaches 2? Does not exist. Now, normally we would not be able to just stop there. We'd have to say the left and the right, but we already have, right? We did that in part A and B. So if it was just that question we had asked, we would have to write down, okay, the limit on the left is 3, limit on the right is 0, cars don't meet, so therefore the limit does not exist. Okay, what's f of 2? That's this output right here. If they were filled in down here and not up here, it'd be 0, okay, but it's 3. X approaches negative infinity. 0. This car is coming down here towards negative infinity, it's heading down towards the y value 0. This one? Negative 2. So as x goes out to positive infinity, it's approaching negative 2. Horizontal asymptote. So x approaches infinity where the horizontal asymptote idea is out there. Sometimes you just get infinity on that or it does not exist. Because sometimes that thing just goes up, up, up like a parabola or down, down, down like an x cubed. So you might get infinity or negative infinity on one of those. You can't do a left and a right when you're doing infinity as x approaches infinity, right? So you could get a does not exist and an infinity or a negative infinity on that. Okay, so that was graphical style limits. Now let's go to a few of these to finish up. These type, let me see here, I'll go to page 30, here's page 30. So let's do, on this page right here, do 7, do 9, do 11, and do 15. first thing you ever do on these limit problems, you just direct substitution. So you plug in a 4, you get 8 over, or no, you get 4 over 3. 4/3, you just stop. You're done. Okay, you plug a 1 into that one, you get 0 over 0 when you do. Something, right? Keep going. One of the options is L'Hopital's rule. Before we learn L'Hopital's rule, would be we can.
Take out 2.
No, that's what we did infinity.
Factor out 2 on the top.
Factor, right? Do some algebra. Now we did do a thing when x was approaching infinity. We talked about how the 2 and the 1 here don't matter. The coefficients of the high powers would be what's left, that kind of thing. Now it turns out to be the same thing here, but that wouldn't be right. Think of it that way, because that's when x goes to infinity, gets really big. But we can take out a 2. So if you take out a 2, so either way, so if we take out a 2, the x minus 1's cancel, and so you get 2. Or L'Hopital's rule, derivative at the top is 2, derivative at the bottom is 1, right? And I thought I heard a quotient rule, maybe I didn't, maybe I heard L'Hopital's rule, but it's not a quotient rule, right? It's just derivative at the top, derivative at the bottom, seeing how fast they're changing. They're both getting small, they're both going towards 0. It's just that the top is twice as big as the bottom, and or getting close to that, so the answer is 2. Okay, number 11,
36.
when you plug in, I think it's 12. Okay?
What did I do? I don't know.
Well,
Negative 24.
again, direct substitution, put in a negative 2. When you put in negative 2 in, you get negative 8 plus 8 is 0, negative 2 plus 2 is 0, so we get 0 over 0. Didn't write that, but we get 0 over 0. Okay? So we got to keep going. Now, there is a factoring thing you can do. I've got it in red over here. Most of you, I'm guessing, don't remember it. I usually don't remember it, although I'm getting better at it. But here, when you have a sum of cubes, yeah, this is back in Algebra 2 class. If you have a sum of cubes, it's, in this case, it'd be t plus 2. Look at the red. T plus 2, and then what's left here is t squared, then it's these two multiplied, but the sign changes to opposite, and then the plus that squared. If it would have been t cubed minus 8, it would have been t minus 2, and then it would have been t squared plus 4t plus 4, like that. But anyway, that's a sum and difference cubed. If you remember it, fine. If you don't, fine. But with L'Hopital's rule, why bother, right? L'Hopital's rule is so much easier there anyway. But if you do factor out a t plus 2, they cancel, you get 12. L'Hopital's rule would say 3t squared over 1, plug in your negative 2, you get 12. Okay? So you just multiply your own. So, anyway, there's another example. And then what about the last one?
It's a vertical asymptotic to go from left to right.
It's a does not exist. You plug in your 3, you get 3 over 0. That's a does not exist. Now, some people say, well, yeah, but you told us that was infinity. Well, right, but it could be negative infinity, and we got to check the left and the right. Okay, it's not a number. When infinity is not an answer because it's not a number. A limit's got to be a number, right? We're going to see one here in a minute. If you get 3 over, if you get 3 over infinity, yes, then you can just write 0, because 0 is a number. And so that's an okay answer. But if you get 3 over 0, you can't just write infinity. Okay, that's not good enough. We're doing x approaches 3, so we have to check the left of 3, the right of 3. And what happens is 2.999 to the left of 3 gives you a real small negative. 3.001 gives you a real small positive. So what you get is negative infinity on the left, positive infinity on the right. So what we have is vertical asymptote at 3. We got it going down there. We got it going up there. Okay? So that's what we would want to write for that one. Okay, just a couple more here. Let's do 26. If you get stuck on that one, you can skip down to 32, 33. Those should be easier. And then think about 26. I mean, 26 isn't that hard, but you have to think about it a little bit. Okay, 32 and 33, got those for sure. We'll talk about 26. Okay, what do you got on 32? Negative 3. This is potentially what you were talking about earlier, right? X is going to infinity. The 7 really doesn't matter. The 1 really doesn't matter on the bottom. It doesn't matter if it's negative or positive infinity. It's just they're getting so big, either positively or negatively big, that the 7 and the 1 don't matter. So it's just the coefficient, since those powers match, because the cubes would then cancel, basically, and you get negative 3 halves. Okay, what about this one? 0. This is what I was talking about. The bottom's getting really big. The 3 doesn't really matter. You got 2 over infinity. 2 over a really big number. Well, that's basically a really small number, which is 0. And it's okay to just put 0 because 0 is a number, and that's what it's approaching. So it'd be like a horizontal asymptote, and this would be the same thing, a horizontal asymptote, negative 3 halves. Now, so let's talk about, actually, let me come back to number 26. I wanted to talk about 35 real quick. Just look at 35 here. What would you say on that one?
If it does not exist,
Does not exist infinity, right? Because the top is a bigger power, unlike this one where the bottom was a bigger power. Top's a bigger power, so that's going to get way bigger than this, and it's just going to go to infinity. She just put does not exist infinity, right? There's no left and right when x is going to infinity. Okay, so back to this. This is a very, the multiple choice matter of fact in our packets today, it's problem number 1, okay, in our review packet. It's very similar to this. Very common problem. By the time we get to May, we ought to be just nailing this every single time, right? Because it's a very common problem that we do. It's a piecewise function. So it says, find k such that the limit as x approaches 2 is equal to f of 2. So if you look at the piecewise function, remember it's just in pieces, right? Well, what do you notice? This is a little different one. Instead of greater than 2 and less than 2 kind of thing, what we have is it's this everywhere but 2. Well, what kind of graph is that? Parabola. So it's a parabola with what at 2? Then there's like a hole, right? There's like a hole at 2. Okay, so what we have is a parabola, and at 2, there's a hole. Okay, and at 2, we have this. Well, depending what k is, it could be this point, it could be this point, it could be a point down here, or it could be filled in, right? It could be the hole filled in, and then we would just have a parabola. What's that? And that most of the time is what we want. We want the hole filled in, because let's look at what they asked. They said they want the limit to equal the output. So we want our dot to be where the cars meet, right? So that's what we want. Now, another way this question is usually asked, though, but sometimes it's asked with limits, but often it's used the word continuous. They'll say f is a continuous function, find k. Or find k so that f will be a continuous function, right? Well, to make that continuous, you got to fill in the hole, right? You got to fill in the hole. So what they're saying is they want k minus 3 to be whatever that y value is right there. Well, how would you find that y value? Put 2 up top. Put 2 into the parabola. Even though it says it's that when x isn't 2, we want it to be that also when x is 2. So we put a 2 in there, and we get negative 3, I think. So what we want is k minus 3 to equal negative 3, which means k would equal 0, right? So, again, there's one where I could see you not having very much work. If this was one on the problem, you say, well, I'm going to plug a 2 in here. That's negative 3. Then I want this to be negative 3. Oh, 0 minus 3 is negative 3, and just getting 0 without really showing much. I think it's a good idea to put this down, even though that's what you're doing. I think I want to get in the habit of showing some of that work. It was a free response. It might want to see that. You might be getting a point for something, showing what you're doing. So I think it's better to get in the habit of doing that. Okay, but not a whole lot to show there, but k would be 0. All right? So, very good. So let's take a look at these packets. So, like I was saying earlier, this is like a full AP style test, although obviously we're not even halfway through the class. So,
you have AP was good.
What's that? Say that again? You got all 4 right now. All right, now.
Wait, you said we're gonna do 4 of these in 4 weeks?
Yes. Now, yeah, but, okay, but listen, like I was saying, you notice that some of them are circled, right? Because this is a full AP Calc test, and so we're not even halfway done yet. Now, we're really close. There are a few in here that we can't do that I've circled. So the circles means, hey, we should be able to do these. When we get to the midterm, we should be able to do the ones that are circled. Now, we're pretty close to being able to do all the circled ones right now. So, and to be honest, many of you are going to go through here, and there's going to be some of you, you're going to say, I don't know how to do this. Well, turns out you should know how to do it, right? But there are a couple, there are a couple that we haven't covered. Now, you still may be able to kind of figure out what's going on, whatever, but part of learning what you know is figuring out what you don't know as well. So I'm not going to make a big deal about going through here and telling you ahead of time, hey, don't worry about this one, you don't know how to do it yet. Anyway, I would just say go and do as many as you can, right, of the circle one, okay? Now, we're going to focus on, again, there's 4 parts. There's a multiple choice part and the free response part, and then each of those is broken up into calculator or no calculator. When we take our final at the end of the year, it'll be on 4 different days because it'll be too long to do, within one day. One section's 55 minutes, another section's 50, the other 2 sections are 30 and whatever. I mean, we could combine it, but we just do it on separate days. With the midterm, we have fewer questions because we're only halfway through the class, so we kind of cut that in half so we can do 2 parts. We can do 2 calculator parts one day and do 2 no calculator parts another. So that's why it's 2 days on the midterm, 4 days on the final. Okay? So to get started then on this packet, what I want you to do is the first section, which goes to number 28. Now let me show you what I'm talking about here. Now when I talk about these packets, notice how this says sample at the top. Okay? I've got 2 different books of practice exams that I draw from. One of them, they always have the word sample. So when I talk about sample 1, when I say, hey, pull out sample 1 packet or sample 2 packet, that's what I'm talking about. Okay? Now the other booklet I have, which is older, they look like this at the front. Okay? So they look very similar, except this one doesn't say sample. It just says exam 2. So I'll say, hey, pull out exam 2. That's different than sample 2. Okay? Just once we get these packets, you'll want to make sure we're on the same one when we're asking questions. Okay, so for tomorrow, if you go to number 28, and I think now in the AP test this year, you're going to have 30 in this first section, the no calculator section. But in this packet, there's 28 because that's what the test used to be. So so here's 28. Once you get past 28, it goes to this section. It says you can use calculator. Okay, but the first 28 is no calculator. I think there's about 14, about half of them are circled. I didn't really count for sure. So basically, that's your assignment for tomorrow, is to do 1 through 28, which is essentially not 1 through 28 because they're not all circled. But do the circled ones in that first section. They're all no calculator. Theoretically, if this was the test, for 14 questions, you'd get 28 minutes. Right? Which is about how much time we have left in class. Now, you're not going to get done that fast. You're not going to go that fast. First time you've seen them, it's going to take you longer to look at it. So I do have answers here if you want to check them. Tomorrow we'll spend the first maybe 15 minutes or so answering a few that you thought were the hardest ones. And we'll work through a couple of them. But you notice this first one's very much like we were just talking about. Piecewise function. It's continuous if B equals 1. Right? Okay, got the rest of the time you can work on this. Very nice. He did not say. He just said, let me read the email. I'm sure he will be. Yeah, he just said send him to me second block. So, and I actually sent him an email and said it'd be around 10:30 or so. So he should be expecting.